और कैसे यार? तो let's solve LeetCode problem 3072. Distribute elements into two arrays. So this is the hard part. Easy part was today, that is very easy. So let's see the hard part now. So what does the question says? We have given one index array of integers, nums of length n. Okay. We define a greater count. Okay. Number of elements in array that are strictly greater than value. Okay. So the greater count function is there that says how many elements are greater than the current value, strictly greater. And we need to distribute the elements into two arrays, array 1, array 2. Okay, we first add nums1 to array 1, nums2 to array 2. Then rest of the elements we add based on the condition, based on these conditions. So, and the array result is found by adding the array 1 and array 2 that is found. Okay, okay. So the question says, if you have a nums array that is 2, 3, 4, 6, 2, right? Then from this one you have to form two arrays, array 1, array 2. First element you will always add to array 2, array 1. Second element you will always add to array 2. Now, when you go from third element, you check how many elements are greater than 4 in array 1 and array 2. So array 1 has 0 element, array 2 has 0 element. Now, if both tie, then you check which array has less number of elements. You see this condition here. So both has equal number of elements. Okay, that means now you are going to add it to the second, this one. So you will add a 4 here. Now next comes 6. You will check both are same and the size of array 1 is smaller. So now you are going to 6 here. For the 2, you will check in this how many numbers are greater than 2. One number. In this how many numbers are greater than 2. Two number. So where we are going to add, where the count is greater. So we are going to add the 2 here. Now final answer will become concurrent of both of these. That is 2, 6, 3, 4, 2. So this is what we have to return. And the constraints are n is given 1 in 5. That means total number of elements, the length of the array will be less than 10 raised to power 5. Okay. And the value of nums of I can till 10 raised to power 9. But total number of elements will be 10 less than 10 raised to power. This is important. We are later going to use it. So always try to check the constant first. Now what the question asks us? What the question asks us? See, we have any time we have an array. Right. In this array, what we have to tell? Number of elements greater than x. This is what we have to tell efficiently. This is the entire problem. This is the entire problem. Okay. Now, the important part is this array will change. This array will update. So, if it's fixed array, you can use binary search, but it's not fixed. If it's fixed, you can use binary search, but it is not fixed. Now, so what we are going to use? Now, this is the entire problem. So, now there are two ways to do it. One is the competitive programmers that use, that is ordered set. Easy, but not interview friendly. But not interview friendly. Now the second approach is the what the norm, what interviewers will prefer. That is our approach. The people who do LeetCode, not code forces. But still, ordered set is very standard. If you remember it, it will help you in a lot of problems like counting inversion. Wherever you have to find number of elements greater or smaller, then you can use ordered set. Now the other approach is the segment tree. Now, or you can use the Fenwick tree as well. So we are going to see this approach today. So you can see this. I prefer segment tree because it is more general. Like I once remembered that template, and for the lifetime I'm going to use it now. Okay. Now the problem is how to build this segment tree. So I'm going to discuss both of these approaches, approach 1 as well, approach 2 as well. If you want to move ahead with ordered set, directly forward kar lo ordered set tak. If you want to see the segment tree approach, let's go. Let's see. Okay. Now for the segment tree approach, first the question is how we arrived, right? How we arrived to segment tree approach. मतलब कैसे पता चला कि हमें segment tree लगाना है? कैसे? Hint, पहला hint क्या था? Array changes. That means updates. Array changes means dynamic. Now, and ask is what? Number of elements greater than x. So can I say is number of elements in range x to some infinity? Infinity is the max number. So that means range query. Now range query plus dynamic update, standard, segment tree. आंख बंद करके segment tree लगा दो. अगर तुम्हें ये पता चल गया है कि रेंज क्वेरी है, डायनामिक अपडेट हो रहे हैं, मतलब एरे की वैल्यूज चेंज हो रही हैं, एरे में कुछ नया ऐड कर रहे हो, एरे की वैल्यूज आप अपडेट कर रहे हो, सेगमेंट ट्री लगेगा अब इसमें। ओके, नाउ अब हम बात करते हैं सेगमेंट ट्री कैसे लगेगा। अब हम लगाएंगे कैसे, पता तो चल गया हमें सेगमेंट ट्री लगेगा। कहाँ गया? हाउ वी आर गोइंग टू अप्लाई नाउ? ओके, हाउ वी आर गोइंग टू अप्लाई? सी, the question says, like, what the question says, the constraints are n is 1 if 5, that means total numbers. Now nums of I, this is still 1 in 9, that is too big. Segment tree is usually 4 times the size that we build. Why? because of because of internal nodes, because of nodes. और अगर तुम्हें ये पूछना 4 टाइम्स n क्यों है, भाई गूगल कर लो, रट्टा मार लो, 4 टाइम्स n ही होता है। सो दैट्स वाई, सी 1 ही 9 तो बहुत ज्यादा बड़ा, बट टोटल हमें पता है कि 1 ही, टोटल 1 ही 5 तक ही होगा। तो कैन आई से कि कंप्रेस कर दे इनको, कंप्रेस दिस। व्हाट कंप्रेस मींस? एवरी नंबर असाइन इट ए न्यू आईडी। हर एक नंबर को एक नई आईडी असाइन कर दो। मतलब हमें गिवन है 2 3 4 6 2, 2 को 1 असाइन करो, 2 असाइन करो, 3 असाइन करो, 4 असाइन करो, 1 असाइन करो। नाउ व्हाट डू आई हैव? 1 2 3 4। सो इफ आई से हाउ मेनी numbers are greater than 3, is it same as how many numbers are greater than 2? Yes. See, number greater than number x equals to number greater than id. Yes. So what is the first step here? Compress coordinates. We are going to dry run using segment tree, but before that you have to understand this compress coordinate. And how will you do this? Just store the values of nums, then sort what values from 1 to some n assigned to values. Store in, say, some key. Key can be of right, int comma int, right? It can be an map, basically unordered map you can use. Now once this has, right, the problem, right, we are we took the example of what, 2 3 4 6 2, right? 2 3 4 6 2. Can I write it as 1 2 3 4 1? Now this becomes our new compressed coordinates. Compressed coordinates, or you can say the new numbers, because we don't care about the number, we only care about how many numbers are greater than it. And even if we compress them, that remains the same, right? The relative order is still the same because we assigned them in ascending order, basically. So if a number is bigger, the number will get a bigger id. If it's smaller, it get a smaller id. Now what is the node, right? What is the segment tree node going to represent? See, our ask was see, ask how many times, how many numbers greater than x in range x to some max. So max will be what? N here. So that means each node will represent what? Numbers in range that node covers. Is this correct? The question asks how many numbers appear in the range x to maximum. So our node will also going to store, right, the number in the range uh, that the node is going to cover. And right, what each position will store? Position in segment tree, leaf node will store what? See, we need count of numbers. If you need count of numbers, then what should be stored? Frequency of each number, right? So this is going to be stored by our leaf node. बस खत्म हो गया, बस यही प्रॉब्लम था। अगर तुम ये इतना समझ गए हो, इफ यू अंडरस्टैंड दिस पार्ट, दिस इज इट, then it's very easy. Now let me explain you with the help of the above example, right? We have 1 2 3 4, and the last one was again 2, right? 1 2 3 4 1, sorry. Now what our segment tree was going to store, see, this is the root node. There is a root node. Now this is some left right child, again some left right. So root, for this one, root node will store what? From range 1 to entire range, right? 1 maximum is what? 4. So this is what going to store 1 to 4. This is left child, store 1 to 2. This one is stored from 3 to 4. This from 1 to 1, 2 to 2, 3 to 3, 4 to 4. This is the range. Okay. So white represent range. Now we are going to see this, and this represent frequency. Now tell me, if I have to put this 1 appeared one time. So this will store 1, right? Because this number, right? This appear one time. This has the initial frequency of 0, 0, 0, because none of these numbers are there yet. So 1 to 2 also has 1. This also is from both of these child, right? 1 here, 0 here, to total will become 1. Okay. Now when the second number comes, that is 2. When 2 comes, this frequency will become 1. So this frequency will change to 2. This change to 2, to this one also change to 2. Now we are going to talk about 3. When 3 comes, this one changes to 1. This one changes to 1. So this propagates up. When it propagates up, 3 to 4, how many numbers are there now? 1. If 3 to 4 is 1, this total, how many this one have total? So 2 from this side, 1 from this side. So 1 to 4 is going to store 3 now. Now, when we come to 4, this becomes 1, this becomes 2, this becomes 4, because 2 is contributed from here and 2 is contributed from right side. This you can say left side, this you can say right side. Now, when again come the 1, so if 1 come, this will change to 2. That means 1 has now come 2 times. If 1 came 2 times, its parent we have to update. So parent frequency will become 3. If parent frequency is 3, the node 1 to 4 is how many frequency? 5. Now, correct? So this is our segment tree. So this is our segment tree. Now, let's answer few queries, right? Now let's answer few queries. So this is important, right? We have to answer few queries. Now, if I ask in the range 2 to, what is the maximum value? 4. So 2 to 4, how many numbers? So you go here, right? 1 to 4. Now 1 to 4, the root node, right? Root node denotes 1 to, root node covers 1 to 4. And what you need? You only need 2 to 4. That means in which side you have to move? To the right side. So you go to 3 to 4 and 2 comes this. So we'll split it, right? This will be your mid. Left child is what? Left child cover 1 to 2. Right child cover what? 3 to 4. Now your range, right? 2 to 4. It lies in both. So this basically overlaps, right? So you now, what is the query now? 2 to 2 and 3 to 4. This will be your answer. Now 2 to 2, this one 2 to 2 has returned what? 1. 3 to 4 is what? This entire node 3 to 4 denotes this return 2. So this is 3. Now let's match. So we asked the question 2 to 4. How many elements are there in the 2 to 4? See, we have 2, we have 3, we have 4. That is 3. And that is what our segment tree returned. Now, if I ask, so what are the cases that can be possible here, right? So tell me cases, right? So for every node, we have a start and we have an end. Now, another thing is what we have? We have our query left and we have our query right, right? This is what we are going to. Now, our middle element, right? Middle element will be what? See, start plus end divided by 2. Now, case will be what? See, no overlap. No overlap means what? See, you have given start and end. These are basically your ranges, right? For if you are checking, let's say this node 3 to 4, then what the range it covers? It covers from 3 till 4 it covers. Now if let's say your query right is 1, that means there's no point in checking 3 to 4, right? The end of your query is 1, then why are you checking for 3 to 4? Right? We simply return 0. So that means what? If for either end less than start, right? That means this was my sorry, end less than what? We have our query right. That means the end, this query left. So this is your end and this is your query left. So that means query left is in right side. So there's no point, right? Or this is start, this is my query right. So either this side, right? Then also there is no. So what I'll say this case, right? So this we are going start bigger than what? Query right. So in this case, contribution is what? Contribution equals to 0. Now, what is the case 2? See, complete overlap. Complete overlap means what? This is your start, this is your end. This is your start node, this is your end node. And here lies your query, here lies your query left. So it completely lies. See, right? This start and end both are inside my query left and right. So that means start greater than equals to query left. Sorry, this will be left and this will be right. And what? This end right and less than equals to query right. In this case, contribution equals to what? Whatever is my at current node. So we'll segment of whatever of my current node. So this is simple. Now case 3 will be what? In this case, we will have a partial overlap. That means some will be from left child and some will be from right child. This particular case. So in this case, partial overlap. So we found our middle, right? Then can we simply say it, right? Contribution from left child is what? Contribution from left child is what? So you will simply say query. What is the left child? 2 times node. So you have to remember this thing. Left child lies at 2 times node. Right child at 2 times node plus 1. You remember these things by heart. Okay. Oh, I think I should have changed the pen. But let me finish this one. Now, start and end, your start and end, right? They will now change. Your start will become what? Start. Your end will become what? Mid. Because now we only check for the left child. Query L remains same, right remains same. Now, plus. What is the contribution of right? See, you will check for right node. Okay. Then you will check for start node. Mid plus 1 will be your start. Then will be your end. Query left, query right. So this is what the all contribution. Only 3 cases are possible, right? Either there is no overlap, there is complete overlap, or partial overlap. So this will be contribution by each of them. Now we have seen how to answer the segment tree and how we build basically. We have already seen this query for build. So I hope you understand, right, how to build it. So let me give you a overview as well. Let me check it to white color actually, right? Okay, so how we are going to build the segment tree? See, in the while building, we have a node, right? Along with the node, we are going to have a position and we are going to have a left or right range. See, base case will be what? If left and right are equal, right? So what happens in case of base left and right are equal? Left and right are equal, matlab leaf node, right? Leaf node stores what? Frequency of each element. So at leaf node, what we are going to do? You are going to do segment of position plus plus, right? Sorry, segment of node you are going to do plus plus, right? For this particular node, you will increase its frequency. Now, if it's not, then what? Then you will check for left child and you will go for right child. So mid equals to what? Left plus right, right? Now, there are two things. You have to update the left child, then you have to update the right child. If you have to update the left child lies as what? 2 into node plus 1. Now, position remains same, left remains same, right will become mid now. But if you have to update the right child, it becomes what? Position left, and this is mid plus 1. Right. Now, how do you know which child to update? You will check here. There will be a check. Check of what? If you are mid, if you are mid greater than position, that means left. That means you are going to do this. Otherwise, right. That means, see, for this, if you have to update for this child, if you have to update node 3, then you will check half will be what? 2. That means in which side it lies? In right side. So that is why you are going to move to the right side. Now, in the end, the current node, right? We will update the parent. Parent, we will update. Again, it's node. Parent, we will update out of both childs. So now I have updated the child. Now I'll update my parent. 2 times node plus 1. So this is the entire segment tree. Now, what is the this build query takes? Of log of n y. You see, I go on only one is either I go left or I go right. So maximum I will traverse is height of tree, right? And height of tree will be what? Log n. Similarly, when I query, similarly when we query this, right? Query. In this case also either we go to the left child or we go to the right child. In case of overlap, we move in both direction, but we will only move until the height of the tree. So the time complexity of this will be also log n. Now once these are done, you can simply apply this, right? You can just simply apply the where we wrote one condition, right? You can just simply apply this condition in which side you are going to edit. Okay. So this is it, the segment tree approach. So if you want the pseudo code, let's actually write the pseudo code, right? See, I have already write build and query, so I'm not going to write the build and query, but I don't, but let's see the pseudocode. There is two array, right? There's ARR1. Initially, it has nums of 0. Then we have ARR2. It has nums of 1. So at this time, you update segment 1 dot update. What? You have to update the key, right? key of nums of 0. Similarly, what we are going to do, we will update what? Key of nums of 1, right? Then we have to loop over what? I equals to 2 till n. Now for each, we have to query both the segment tree and find how many elements are greater than it. Okay. So when you update, you will also have to pass, right? What we have to pass, there are position, node, left, and right. So position will be what? Nums 1, node will be what? 1 because initially the parent, left will be what? 1, and right will be what? And n is what? Maximum. Okay. Now when you query, G1 equals to what? Segment 1 dot query. So what you want to query? You want to query, right? Key of what? Nums of I, right? Key of nums of I plus 1 because you need strictly greater. Now node will be what? 1. This is the start. End will be what? This one. Node is what? This one. And what is my query range? This is the query range, right? Query range. And what is my start and end? Start is 1. End is what? N. This is the maximum range that is possible. That is what my root node contains, right? Similarly, we do the G2 S2 dot query. Now we will apply the case, right? If what? G1 greater than G2 or G1 equals to what? G2 and अगर या तो if G1 बड़ा होना चाहिए otherwise what? G1 equals to G2, then what we are going to do? We will check whose size is smaller. We will check, right? If what array 1 dot size less than what? Array 2 dot size, then where we are going to update 1, right? Array 1 segment 1, else what? Array 2 segment 2. So let me just write one query, right? You are going to update what you are going to update, right? The key of what? Nums of what? I. Now again, what is that start and end that we put above, right? 1 start is 1, end is what? N. So this is what the entire code is. So in the end, just right, you need to append this b, right? A dot append. Append is I don't think any function, but just loop over it and add it, right? Loop and add, and you can simply return array 1. So this is the answer. And what is the time complexity? This one runs in n loop. This one runs in log n. This one also happens in log n. So this is n log n. Understood? Okay. Now let's see the ordered set approach. See, ordered set approach, right? Ordered set approach is pretty much easy. Ordered set has two functions, right? Second, right? Find first is find by ordered, and another was in ordered. Uh, what is that? Order of key, I think, right? Order of key x. What it returns? Number less than equal to x. This is what it returns, and this is returns the iterator to that position. Think so. I'm not sure about this one, so check, verify. So this is important, and mostly this is the one that is being used. So see, if this number returns what is less than equals to x, then this is simple, right? If your ordered set is like 2, 3, 4, and you check, right? This is your ordered set. You check, right? Order of key, and you check, right? 3. Then what you will get? 2. These two. Then strictly greater equals to what? Strictly greater equals to what is the size, right? The size, right? Size what? 3. That is size minus what? Order of key, right? This is strictly greater. Now there is one catch, right? This order of this, right? Ordered set. This only has distinct values, but we can have equal values. So to avoid that, what we are going to use, we need to make our value unique. So to make that unique, we are going to use a pair of what? Our value, comma, index. See, if we store a pair of value, comma, index, that means each index is unique, right? Each index is unique. That means this value becomes unique, right? So this is it. Now this is, you have to first import the this PVDS libraries that you can check anywhere on the Google. Then simply it's right. You declare two ordered set. You initially add nums of 0. In this you add nums of 1, comma 1. This is 0, right? We have to add that index as well. Now when you query greater 1 equals to what and greater 2 equals to what? So greater 1 equals to what? OS 1 dot size minus, right? Ordered of set, right? This order of key. Now you tell me this condition. First is nums of I. What will be this value? So answer me in the comment section what will be this value. And the same you will do here. Now then if this is same, then apply same condition. Apply same condition. This is very simple. And if you want to see what is the same condition, I added that in the segment tree approach. So this is basically G1 greater than G2 or G1 equals to G2 and this, right? The size of first list, right? Or you can say order 1 dot size less than order 2 dot size, right? Then you add to what? OS1 comma array 1, else you would add to OS2 comma array 2. So that's it. This is pretty much simple. So let me answer this as well. This is going to be the maximum index value, right? So this is going to be the n plus 1. And why n plus 1? Because order of key give number which are less than equal to the current value. So if you want a value that will always be less than equal to the current value, then your unique pair will be what? See, you can have a value which is equals to nums of I, but the second value will be what? Index. But if you provide maximum index till now, that means all values will be smaller than it. So that's why it's going to be the maximum index. So the time complexity will be also of n log n. So this is it. I will provide a link to the actual code in the comment section. And if you want to see the actual code, before code I will suggest you write the pseudo code by yourself by hand, because this is the one approach, right? The segment tree approach. This will be used in a lot of hard question. If you can solve till medium and you are struggling at the hard part, so that means you can definitely know how to write the code. The only part that is left is how to get to the intuition. And the intuition I told you how I reached to this. So go ahead, write the code, and once you are able to write the code, comment in the comment section how you did it. Okay.